Hi, welcome to my channel, JaberTime. Today I'm going to talk about the chain rule and its cases. The chain rule. When you have y equals f of x and x equals g of t, to go from y all the way to t, you have to go through x, as you could see right here. dy dt equals dy dx times dx dt. Here's case 1. Z is a function of x and y, is differentiable function of x and y, where x equals g of t and y equals h of t. So both variables x and y are actually functions of t, are both differentiable functions of t. Then z is a differentiable function of t itself. dz dt will be df dx times dx dt, because that's the main variable t. You have to go all the way to reach t, plus df dy dy dt. Here's an example. Z equals x to the second y plus 3xy to the 4, such that x is a function of t, as you could see, and y is a function of t. We want to go all the way to t and find dz dt when t equals 0. Since I have x equals sine 2t and y equals cosine t, when t equals 0, we get x equals 0 and y equals 1. Here's my main function. Here's dz dt, which is dz dx times dx dt plus dz dy times dy dt. At t equals 0, I have the derivative of z with respect to x will be 2xy plus 3 times y to the 4th, as you could see right here, and I have dx dt equals cosine 2t times 2. The rest you could verify from here. Same style, same pattern. Now here I have enough numbers to plug in, which is 0 for x from here, 1 for y from here, and 0 for t from the original problem. Once you take care of that, I have 3 times 2 plus 0 times 0, which is 6. The pressure P in kilopascals, the volume is in liters, and the temperature is in kelvins, of a mole of an ideal gas are related by PV equals 8.31 T. Find the rate of which the pressure is changing when the temperature is 300 K and increasing at a rate of 0.1 K per second, and the volume is 100 liters and increasing at a rate of 0.2 L per second. To get started, I have the problem here. PV, or the formula, equals 8.31 T. Let's write it as P by itself. P equals 8.31 T over V. Find the derivatives. Those are the given information from here. I don't want to read it back again, but as you could see, T is 300, V is 100, and so on. dP dt equals the derivative of this with respect to t, so it's going to be 8.31 times 1 over V. dP dV, because V is in the denominator, you could apply the quotient rule and you get the following. Now dp dt is dp dt times dt, capital T, over dt plus dp dv dv dt. This right here is from the left hand side, as you could see. dt is 0.1, which is right here. It says, and the temperature is 300 K and increasing at a rate of 0.1 K per second. Temperature is increasing at 0.1. dp dv is right here, and dv dt is 0.2, which is given to me right here. The volume is increasing at a rate of 0.2. Now when t equals 300 and v equals 100, I'm gonna take these numbers in, do the math, simplify the numbers, and end up with negative 0.4155. It's a lengthy problems and section, and even the coming sections will be longer. So if you feel like I'm going too fast, I'm not reading every single part, you could pause the video by hitting the spacebar, as I told you earlier in previous videos, and you could hit the spacebar again to make it play again. So the conclusion: the pressure is decreasing because it's negative at a rate of about 0.040 kilopascal per second. Let's talk about case 2. In this case, we have z equals f of xy, where x is a function of two variables and y is a function of two variables. So z is a function of x, but x is a function of two variables, s and t. Same for y. So now we have dz to go all the way to t, or dz going all the way to s. So dz dt will be dz dx, dx dt, plus dz dy, dy dt. Same thing for dz ds. Here's an example. z equals e to the x sine y, x equals s t to the second, and y equals s to the second t. We want to find dz ds and dz dt. So once you know the formula, you just apply it step by step and it should be fine. Let's take care of the first one here. dz dx is e to the x sine y. To find derivative with respect to x right here, this acts like a constant and this doesn't change, so the whole thing is the same. Let's look at dx ds. The derivative of this with respect to s will be t to the second. dz dy, the derivative of this, this part right here with respect to y, sine y will give you cosine y, and this will stay as a constant up front. dy ds will be 2st, 2 will go up front, and t will act like a constant. Simplify, and that will be the answer. On the other hand, dz dt will be dz dx, dx dt, and so on. Let's take care of one at least. dz dx. To find the derivative of this with respect to x, this will act like a constant, and derivative of e to the x is e to the x. dx dt will be 2st, as you can see, and the rest will follow. Instead of reading it, I'm just giving it a few seconds so you could take a note out of this, and so we could move on. Now, if g is a function of s and t as defined, and f is differentiable, show that g satisfies the equation t times dg ds plus s times dg dt equals 0. In other words, they would add up to 0. Now we're going to call this one x, we're going to call this y. Then g of s of t is a function of x and y. Let's find dg ds, this part right here by itself, right there. And we're going to find the other part by itself right here. We'll just follow the formula. Dg ds equals df, as you can see from here, df dx times dx ds, because we're going after s, plus df dy dy ds. df dx is right here. dx ds is 2s. dx ds will be 2s, and the minus t to the second will cancel, will be 0. Same thing right here. dy ds will be minus 2s. Let's look at this part right here. dx dt will be minus 2t, and dy dt will be 2t. If we go back to this right here, and we take care of this and this, put them together, with a simple algebra, everything will cancel. For example, you see this part right here, multiplied by t will be minus 2st df dy. I have it here, multiplying by s, it's positive 2st df dy will cancel. Let's look at the first part. That's going to be 2st df dx, and this will be minus 2st df dx, which is going to cancel too. It's just like practice of the differential, the chain rule. Implicit differentiation. When you have a function of x and y equals 0, defines y implicitly as a differentiable function of x. That is, y is a function of x by itself. We could write this f of x and f of x equals 0. Now we have the following: df dx, dx dx, because we don't have t now or s, plus df dy dy dx equals 0. But here, if you look at this one right here, that's a 1. And df dy is not equal to 0. If it's not equal to 0, we could divide by this. That's the reason why here we have it does not equal to 0. We're going to solve for dy dx. Solving for dy dx by having, let's say, everything right here on the right side, which is minus df dx, and after that divide by this, because it's not equal to 0. It looks like this. It's kind of like too much to look at, so here's a simple form for it. dy dx equals negative capital F with an index x, that's df dx, and capital F with an index y, that means df dy. Now, if you want to find y prime of this function, we're gonna start by the following. We're gonna move everything to the left, because if you remember from the previous slide, it was called f of x, y equals 0. So if you move everything to the left, now I see the 0. And that's my function f of x, y equals 0. It's this function right here. Just like what I just mentioned, alright? Now, dy dx is minus fx over fy, which is equal to the derivative of f with respect to x. Let's go back and look at it. This is my f. To find the derivative with respect to x, that's going to be 3x to the second. This will be 0. And this will be minus 6y. Fy will be 0 here, 3y to the second, minus 6. That should be 6x. That should be 6x. That's a typo. I have it fixed, I believe, in the second step. Yes. That's good. That should be 6x. The only thing that I went from here to here is 3 and 6 and 3 and 6. They all divide by 3, so that should do it. So the answer, yeah, it should be x. Okay. Let's move on. Now suppose that z is given implicitly as a function of x and y. Z equals f of x and y. That means we have now f of x and y and z, where z is a function of x and y equals 0. It's similar to what we have, except it's going to take one more step to finish the process. So that's my function. For all x and y in the domain of f, df dx, dx dx plus df dy, dy dx plus df dz, dz dx. You could see the final step is dx. Now looking at these parts, this is 1, dy dx is 0, because z is a function of x and y. It's not like y is a function of x and x is a function of y and so on. Z is a function of x and a function of y. So, what we have now is df dx by itself and df dz, dc dx will add up to 0. Solving for dz dx, moving this to the other side, which is going to show a negative sign, dividing by df dz, I have the following, which is written in short. In the same way, we could follow the same process right here and go after df dy and just keep going. We end up with dz dy equals minus fy, I'm reading it kind of like fy to make it short, over fz. If you notice, when you go dz dx, it's fx over fz. So it's kind of like you're switching the letters if you want to make a note out of this. Look, zy, yz. Okay? Here's an example. If you want to find dz dx and dz dy, we have our function that is equal to 0 is everything here moved to the left, like moving the 1 to the left and calling it calling it 0. So to apply what we know now, dz dx will be minus fx over fz. Just find the derivative of this with respect to x, find the derivative of the whole thing with respect to z, divide, simplify, and you should be done. Let's take a look. Derivative of this with respect to x will be 3x to the second, and this will be 0. This will be 0. Derivative of this with respect to x will be 6yz, as you could see. Same thing you could apply for z. This will be 0, 0, 3z to the second, and with respect to z, this will give you 6xy. 6's and 3's will simplify, divide by 3, as you could see. In the same way, we could find dz dy equals minus fy over fz, and you could just verify the steps. Let's just go over the fy at least. Derivative of this with respect to y, that will be 0. This will be 3y to the second, and with respect to y here, you will get 6xz as it shows right here. And the rest I'll leave it for you, just to save some time from recording the video and not making it over 30 minutes. Alright? It's just like a chain rule, case 1, case 2, and implicit differentiation, which you could practice and follow. It's not really complicated or hard to practice. Okay? Thank you for watching, and I'll see you in the next one. Thank you. Thank you for watching. Don't forget to hit the like button, subscribe to see some more, and I'll see you in the next one.